Bismillahirrahmanirrahim. Today I am going to tell you people about the spectrum of hydrogen atom, and as we have studied and we have discussed in the previous lecture what is actually the atomic spectra, and that was so simple, and the main thing was actually the transition of the electron. If you know the transition, so I think there will be no trouble for you people, and there will be nothing about difficulties to learn about the spectra. So today my topic of uh, lecture number 2 is actually about spectrum of hydrogen atom. Before going to take a start of this topic, I'm going to tell you about one of the general information which is related to spectra, and spectra is important, and I have discussed in the previous lecture many importance related to spectra, but you can add one thing more, and that is actually related to the spectra and information about the spectra. And that general information is, you can say that, and many of the astronomers are using actually this spectra, and this spectra is using in the identification of the material, especially on the surface of sun. So on the surface of sun you can find out the material, that what kind of material is there on the surface of sun. So that identification can be determined by the help of spectrum. So spectrum is very important, and that is you know already that this is actually a sort of a fingerprint, and this fingerprint can we give because of this fingerprint we can get a lot more information about anything which is too far away from us, like sun. Sun is too far away, and if you want to find out the information, and if you want to find out the identification of the material which is present on the surface of sun, so this is not too difficult. And this is difficult, by the way, simply if you look, but this is not that much difficult if you go to the level of spectrum, because this spectra will tell you much more. So today our main concern in the topic is all about a spectrum of hydrogen atom. So okay, I mean that actually whenever we are getting a spectrum from the atom of hydrogen, so that spectrum will call a spectrum of hydrogen atom. Now here the question arises, why we are using the hydrogen atom, why not other atoms? So we can use other also, but one of the most simple atom is actually hydrogen atom. So hydrogen is very simple and having only one electron, and you can get the information very finely as compared to other elements which is present in the universe. Okay. So before going into detail of this topic, that is the spectrum of hydrogen atom, we have to know about the full electromagnetic spectrum, that what actually electromagnetic spectrum is. So full electromagnetic spectrum is very important to know about. So before going into detail of this topic, you have to know about the full electromagnetic spectrum. So now I want to explain generally that what is electromagnetic spectrum, and you should have to know about, because this thing is important, and if you know this whole thing, you will then be able to learn about hydrogen atom very easily. So the spectrum can be drawn like this. For example, you are having visible part in our system in a light, and then you are having infrared region, and then if you are increasing the wavelength of that light, so you will get to go to the microwave region, and then so on, radio waves and things like that. This is the spectrum. And if you are having to decrease the frequency, or you are increasing the frequency, or you increase the energy, so you will go toward left. And if you are going toward left, there will be ultraviolet, and there will be X-ray and gamma ray and cosmic ray. Actually our topic is actually hydrogen atom. So our main concern will be about what? We have to keep this in mind, that actually the information that is we are getting from hydrogen atom, or the spectrum that is we are getting from hydrogen atom, is actually will be in the region of this one. So this portion is very, very important. I mean, infrared region, visible part, and ultraviolet region is one of the most important part of the lecture today. Here I have discussed these stuffs also, and this is because that you have to know about the electromagnetic spectrum, and that spectrum is important to learn about. Okay, so ultraviolet region, visible region, infrared is our main concern. So actually you must have to be in a position that actually electromagnetic spectrum is not our whole topic. Our main concern is actually in hydrogen atom. But before that explanation, you have to know about these stuffs as well. Otherwise, if you don't know about these stuffs, I think then you will have a confusion in the lecture of that topic. So okay, that is why I have selected and I have decided to share this thing also in this topic. Now, what is actually this thing? You have to know about that. This is cosmic ray, gamma ray, X-ray. This is much more energy as compared to this one. Gamma ray has much more energy as compared to X-ray, and X-ray has energy greater than that of the ultraviolet one. And then visible, and then infrared, and then microwave region. And this is you can say a full, and you can go on like radio waves and things like that. So this is a full spectrum. So actually we are getting a spectrum of hydrogen atom, and that spectrum will be in the region of these three regions: infrared, visible part, and then ultraviolet. Now the question arises, why ultraviolet, why infrared, why visible part, why not X-ray, and why not gamma rays, and why not things like that? Actually the reason is actually the transition of the electron, and that transition result to the light. That transition is actually result to the light because it is coming from high level to the lower level. So actually these light are totally correspond to this region, and the correspondence is actually because the energy level is not that much. It's not that much to give you the light of X-rays or the light of gamma rays. So this is actually a full light, and we are having interest today in this lecture is all about only in this portion. Okay, then after that, if you know the electromagnetic spectrum, I think there will be nothing about to know what is ultraviolet and what is visible part and what is actually the infrared region. So this is a general discussion about that. Now the topic is actually spectrum of hydrogen atom. Before going to the spectrum of hydrogen atom, you need to know about the transition of electron, which is very, very important. And this is a very, very simple mechanism, and I have discussed that in a previous lecture, but here I am modifying that lecture. A little bit of modification will be here. So for example, you are having this is an atom of hydrogen, okay, specifically hydrogen atom. These are the shells. Now this is the nucleus, you can mention it with a positive charge like nucleus. And the nucleus is surrounded by the different shells, like n is equal to 1, n is equal to 2, n is equal to 3. N means number of shells. Number of shell equal to 1, shell equal to 2, number of shell equal to 3. So n is equal to 4, n is equal to 5. Okay. You should have to know about, and this is a very simple diagrammatical representation of the hydrogen atom. Now you know that hydrogen atom is consists of only one electron. Okay. Suppose that this electron is in the first shell of the atom, and there is actually what's happened. The external agent comes, and actually the electron is ejected from the first shell to any of the other shell. For example, an electron is ejected by the external agent from n is equal to 1 to n is equal to 6. Suppose. Now these electrons come here now. The shell here, the electron in the first shell create vacancy. There is no electron. Now this atom is now become excited, and now this atom want to be stable and they want to have a stability, and stability is very, very important, and this is I have discussed in the previous lecture. So this electron want to get stability. For that stability, that electron will transit and it will move from a high energy level to the lower energy level. I mean that will goes from n is equal to 6 to n is equal to any of the lower shells. So for example, if this electron want to get stability and move from n equal to 6 to n is equal to 1 again, suppose. So this electron which is moving from n is equal to 6, this electron which is moving from n is equal to 6 to n is equal to 1. So what's happened? Actually, sorry, you will get a photon, or you will get light, and that light will have their own frequency and wavelength. So why actually photon is released? Because it wants stability. Here the electron wants stability to go there. So n is equal for when it moves from n is equal to 6 to n is equal to 1. This release energy, and that energy will be in the form of light. So now the question is, the light is, the full electromagnetic spectrum, as I have discussed before, that the full electromagnetic spectrum consists of X-rays, gamma rays, visible part, infrared region, microwave, and many others. Okay. So what kind of light actually do we get here because of the transition inside the hydrogen atom? So we are getting the light. That light will be in the range of ultraviolet rays. Now the question arises that from where do we know that actually this is ultraviolet rays? So this can be answered by a very simple and a very important and a very useful formula. That is actually 1 over lambda equal to Rydberg constant times 1 over nf square minus 1 over ni square. Now what is here this one? What is lambda? Lambda is actually the wavelength of that light, which is obtained because of the transition of electron from one shell to another shell. And what about this one? This is the wavelength of light. That is we obtain from where? From the transition of electron. And what is this? This is Rydberg constant. And this Rydberg constant is equal to 1.09 something into 10 to the power 7 per meter. This is Rydberg constant, sorry. And what about this one? This is Nf is equal to, this is actually the final shell. I means this is the shell where the electron gets stability and where the electron get totally stable. For example, this shell n is equal to 1. Here the electron coming from n is equal to 6 to n is equal to 1. Here it gets stability. So that stable state can be represented by Nf. Okay, and this is, you can say, the stable state of electron. What about Ni? Ni is actually, you can say, the initial shell. Initial shell means that whenever the transition is taking from any of the shell to any other shell, and that transition, for example, here is n equal to 6 to n is equal to 1. So Ni is equal to 6. So this is actually the shell where actually this electron was in a excited form. So that is why this is the stable, this is an excited, you can say excited state of electron. Okay. So this was the general and simple description about this formula, and this is the general formula from which you can find out the wavelength of any of the wave which is emitted by the hydrogen atom because of the transition of electron. So I think transition of electron is very, very important here. Now we are getting a different kind of wavelength of light because of the transition of electron inside the hydrogen atom. So what kind of light are actually what kind of lights are we actually obtained? We are actually obtained different kind of lights. For example, if the transition is taking place from n is equal to 6 to n is equal to 1, so this will giving you the light, and that light will be in the region of which one? So we will have to discuss this thing, and this is actually, this is, you can say this is Lyman series. This is Lyman series. What is Lyman series? This is Lyman series. Lyman series is the series which is occurred only if the transition is happening from any of the shells to n is equal to 1. This will result to the light, and that light will be in the series form. This is called Lyman series. For example, if n is equal to 6 to n is equal to 1, you will get light of that kind. Now if the transition is from n is equal to 5 to n is equal to 1, so that will result you the light again. But this light wavelength will be in which region? So actually that will always also be ultraviolet ray. Now if a transition is taking place from n is equal to 4 to n is equal to 1, again ultraviolet ray. But what is the difference? This is high frequency, this is less than that, this is much less than that of this one. So if the transition is from n is equal to 2 to n is equal to 1, again ultraviolet. But the difference is only in the energy and the frequency. So this kind of a series that has been obtained by us with the help of the electronic transition, this series is actually called Lyman series. So Lyman series is actually happen only if the transition is occurring from any of the shells to n is equal to 1. Any of the shells around the nucleus to n is equal to 1, I mean to the first shell, this will result to the ultraviolet rays, and this will be lie in the portion of ultraviolet. And this series of rays that is obtained because of the transition inside the atom will be in the range of Lyman series. So okay, now this was all about a Lyman series. Now what about the Balmer series? Balmer series. So the series of the different wavelength of light that is obtained whenever the transition is happening and whenever the transition is occurred from any of the shells to n is equal to 2. Any of the shell around the nucleus to n is equal to 2. This will result to what? This will result to visible part. This will result to the visible light, and that visible light which is obtained in the series form, this is called Balmer series. For example, if the transition is from n is equal to 5 to n is equal to 2, then this transition of electron will result to what? This will result to the light, and that light will be in the range of visible one. Okay, if the transition is taking place from n is equal to 3 to n is equal to 2, this will again visible part. This will again visible. This is visible, this is visible. Now if the transition is from n is equal to 6 to n is equal to 2, again it will be in a visible part. But the difference is only will be in the energy. Here you can say the wavelength of this will be smaller as compared to this one. And the wavelength of from n is equal to 6 to n is equal to 2 will be, this is n is equal to 2 actually, this is n is equal to 6. So from n is equal to 6 to n is equal to 2, this will result to the light, and that light has much more energy as compared to others. So it will be like this. So this series of light which is obtained because of the transition of electron inside the hydrogen atom is called what? This series of visible part, this series of visible part is called what? This is called Balmer series. And we are mentioning the name of scientists because these people work on it, and possibly he did a very fine job. Okay, and what about the next step? Actually, if the transition is happening from where? Now the third series is actually, this was the Lyman series, this is Balmer series, and now coming toward the fast-chain series. Fast-chain series. When will actually fast-chain series came into play? Fast-chain series will happen only if the transition of the electron occur from any of the other shells other than n is equal to 3. I mean, if the transition is happening from any of the shell, n is equal to 7, n is equal to 6, n is equal to 5, n is equal to 4, to n is equal to 3. If the transition is from n is equal to if the transition is from n is equal to 4, 5, 6, 7, 8, etc. and so on. From any of the shell to n is equal to 3, then we will get partial series, and that light will correspond to which one? This light will correspond to the electromagnetic spectrum, this light will correspond to the electromagnetic spectrum, and that electromagnetic spectrum will lie in the range of infrared one. Okay, so that will be lie in the range of infrared. For example, this is n is equal to 2, n is equal to 1, n is equal to 3, n is equal to 4, n is equal to 5, and n is equal to 6. So if the transition is from n is equal to 6 to n is equal to 3, you will get the light will be in the infrared region. Again, if the transition is from n is equal to 6 to n is equal to 4, again if the transition is from n is equal to 5 to n is equal to 3, you will get again the light, and that light will have greater wavelength than that of the infrared one. Then from n is equal to 4 to n is equal to 3, again you will see the infrared part. And why actually you are actually seeing that there is a little bit of difference in the wavelength? The difference is actually because that if the transition is from n is equal to 4 to n is equal to 3, this will result to less wavelength, greater wavelength. This will tell you about the greater wavelength. This is the greater wavelength. And from n is equal to 6 to n is equal to 3, this will show you the less wavelength. It means that this ray, and this one, which one has greater energy? This one has the energy greater, means frequency is greater. Here the energy will be less, means frequency is less. Here the energy will be in between. It will be in between these two. So because of the transition, if the transition is from far shell to the inner shell, this will result to the energetic photon. And here if you are comparing these three infrared rays, so which one will have greater energy? So I think this one will have greater energy because the transition here is from far shell n is equal to 6 to n is equal to 3. So actually this was about the Lyman series, Bulbert series and Parsons series. There was nothing typical actually inside. Only the main thing is just transition, and you are getting light, but that light will correspond to which part of the electromagnetic spectrum. Now, one thing which is important. Now, who is actually responsible for giving us the wavelength of each of the light? Actually, the responsible portion of this thing is actually what? This equation tells you all the information. This equation, I can say that this equation has much more information in hidden form. In hidden form, a lot of information is here. If you are putting the value of R and F, for example, in F is equal to 1, if this is 1, and this is Ni is equal to, suppose a transition from 6 shell, N is equal to 6 to N is equal to 1. So 1, 6, 1, 1 is 1. So if you are calculating this value, this will result to the wavelength of which one? This will result to the wavelength of ultraviolet rays. And this will result to the ultraviolet rays. And that is why we consider this a general formula from which we can find out different wavelength of the light. And this is very, very important to know about this one. Now another question is that from where actually this formula came. Actually it came from the derivation, and that derivation is very simple. But here if I want to derive this equation, it will waste a lot of time. Because of that, you can have to just remember this formula. And if you want to derive it, you have to visit the chemistry, first year chemistry book, and you will see inside the and search for the chapter atomic spectra. So you will see the derivation. But here our concern is not with the derivation. Here our main focus is only on the information, that what kind of information we are getting from the hydrogen atom. So that information is what? That information is actually spectrum, and this spectrum is very, very important. So this is a sort of spectrum. This is spectrum, okay? Light of different part, different wavelength, different light wavelength in a different region of electromagnetic spectrum. So this was all about the spectrum of hydrogen atom. And if you people are having any kind of a question related to this topic, you can ask, and inshallah I will answer you. And please comment on, please pass out the comments in the YouTube channel in a comment section. So I think this will be better, and we will share knowledge with one another. And thank you so much for having fun with us. And we have to enjoy this topic really much. We have to enjoy all these, and you have to think conceptually, so that could be much better. Okay, thank you so much for your time, and don't forget to subscribe my channel of YouTube.